Hello everyone. In the last session, we discussed about how to access select database table if you have SAP HANA as a secondary database. So how you perform a select query on a secondary database connection and performance tools, static performance tools such as SCI and ABAP Test Cockpit. So in this session, we will be discussing about runtime consumption. So runtime consumption tools such as ABAP Trace and ABAP Profiling Perspective. For ABAP Trace, the transition is called as SAT. So, and ABAP profiling perspective, this perspective is present in ADT, ABAP development tools. So, I will be going to system now and open the report, open the transition SAT. So, if I open SAT transition, so if you see this SAT transition, so this is runtime analysis ABAP Trace transition. So for this transition, you can give any program, or you can give any function module, or you can give any transition. So it will return you how much how runtime consumption it took for the program to execute and the transition to execute as it will be evaluated. Suppose if I give the program function module, suppose BUP select with partners, and this is defaultly selected this function module. I'm just clicking on execute. So clicking on execute, it is asking for the input for me. So or else this is standard function model as of now. I'm just going back. So if you see the hit analysis it gave me, so I'm just closing this. I'm selecting the program now, and the program name which I will be giving now, the program which we created previously, like for a OpenSQL connection, ABAP OpenSQL connection. So I will open that program, CAT. So here we have a program, OpenSQL secondary DB connection. So I will give this program. So it will give the home runtime conjunction of this program. So I will be selecting here Control V and execute. So as soon as when I click give the program, click on execute, it will give me the runtime analysis it took for the ABAP report program. It will use to record analyze the traces. It will use it for recording and analyzing the traces, and shows the traces captured on application expensive events. And it indicates this ABAP traces also indicates benefits for identifying optimization. So ABAP traces here helps to investigate applications behavior, how much time the application, how it is behaving. So I'm just clicking on back. So it will give me the hit list. If you see create hit, it is giving a hit list for me. So it gave me a hit list saying which statement is executed. In if you see this DB fetch, if I go to database accesses, internal and external, if I go to database accesses, external database, so fetch, it will fetch me the statements which took so much time to fetch from the DB. So if you see OpenSQL DB connection calling a program. So it is taking to fetch mark 61 hits. It clicked on mark. So it took 1417 microseconds to fetch these tables from the mark, and it took 925 microseconds. I mean microseconds. This is microseconds. So this is maybe 925. Uh, it is measured in microseconds. So 925 microseconds. This will be around 1 lakh. Means it took 1417 seconds, 925 microseconds. So it took to get from the SNWD BUPA, and it took another hit from 19 SN BUPA. So how much time DB access? How much time it took to get the DB access? It's fetch the same. So if I double click here to do this statement, it will give me the statement which is executed a large time. So here this statement executed for overall hits was 30, 35,000 hits overall in the database to fetch the records, and it will the gross amount it took was uh, around 17,744 microseconds. So net and gross, everything will be displayed using profiling perspective. So here ABAP trace identifies the ABAP code that performs, which ABAP code performance has to be improved, analyze the runtime behavior, and it shows the critical code executed, and it understands the performance issues which originates from. So improve and one of these tools to perform such runtime analysis was SAT here. So before the tool was SC30, so it replaced with the new transition SAT. So here this tool is used for checking the hit lists. So if you see, you can see the hit list, how much hit list it took, and what are the DB tables associated here. So the DB tables was SNWT BUPA, mark was the table. So these are the some of mainly these two tables was present in this. And if you go to profiling, you can, if you wanted to see runtime analysis, suppose. So you can see runtime analysis it took. So number was runtime analysis. It took only 31,173 cross it took, and database internal processing blocks like perform. If you have any performs, so how much time it took to execute a perform, so can be seen here. So times, it gives the times, runtime analysis times. So it took 31,173 seconds totally, 31,173 microseconds totally. So he see, and how much data buffer it took, and to load the report, how much time it took. So you can analyze using ABAP trace. So these are different types of times you can see here. So you will be able to go to desktop, and you will be able to see data access internal, and you can see in the persistent data SAP SQL. So how much time it took to fetch, and how much time it took for only OpenSQL. So if you see, this is the gross amount it took for the executing OpenSQL. Gross amount it took to fetch was this much, so 18,753. Select single statements, how much, only one select single was there. So how many close cursor statements it took. So when you close it took how much microseconds. So these can be checked using ABAP trace. So runtime analysis can be tracked using ABAP trace here. So you will use this to record the trace. You can display the trace, and here it records events during ABAP statements. It's are executed within a work processes, and it compares to, you can compare two ABAP traces as well from this SAT. So here expensive operations on internal tables and unnecessary calls to processing blocks, long running modularization units, nested loops, uh, loops statements, and program flow can be seen here. It reduces approach for optimization actually. So if you wanted to access for the entire system, it's not a good performance tool which is used to track the performance. So it is used for only to track any transition, to track any function module, to track any loops, to track any nested loops. You can have any perform statements in your program, then subroutines. Then you will be able to have this gross and net amounts it took to trace this. You can trace this using SAT. So hit list will be, you can have hit list, what are the DB tables associated with that, what are the profiles, so how much profiles like database external internal profiles, and you can see times which took, each statement took how much time can be analyzed. So these type of measurements you can do it using SAT trace. So you can do it for a transition as well. This trace can be done in a transition level as well. So now I have shown you the trace for a program level. So if you wanted to trace for Suppose I'm opening SAT transition. If you see, the variant was default. You can create a new variant as well here, and perform trace as well. So when you create a new variant, you will be able to check for which statements you need to select, which program parts you need to. So you can select and you can create a variant, and you can perform trace accordingly. So maximum size of the file you can set for call position and statement, which type of above statements like methods, processing blocks like methods, events, function modules, subroutines, and database access like OpenSQL, native SQL, context and screens, and data transfer, internal tables, and load functions. So program cards like if you have to set any limitations for the programs, these can be set here. So you can create a variant and you can execute based on the transition, program, and function module. So I can do for the transition as well. Suppose if I want to do it for the transition BP, suppose. So BP is a transition for creating a BP. So I'm just taking this transition. What I will be doing is I will select, so execute. Okay, from user. So I'll open again a setting. So I'll give BP now. So when I click on BP, so it will go to transition BP. So this is the transition where you will access any BP. So suppose if I'm opening any BP and doing some fetching the details of the BP like addresses and like identification, and if I go back, so I executed the transition BP with some details like control. So I can go back now. So now what happens was it will result me the ABAP trace hit list. So it will give me the hit list, how much gross amount it took to how much gross time it took to fetch from the RFC, or how much what are the tables associated with this BP. Suppose BU000 is the main table, and how much cross time it took to fetch the data, and ADRC table for address, and the time dependent addresses, and suppose ADRTT is address text. So what are the time taken by each ABAP statement like processing blocks? So how much time it take to open, how much time it take to fetch the tables, and you can see the hit list from different uh, uh, DB access as well. So SAT is a transition tool which is used for runtime consumption, how much performance it took to analyze. It is used for analyzing the runtime analysis as an SAP application trace tool. So next, coming to next ABAP profiling perspective. So ABAP profiling perspective was there in it was present in HANA Studio. So I'll open the HANA Studio here. So when you open HANA Studio, so you will be having ABAP profiling perspective in your HANA Studio. So that is used to do ABAP ABAP trace. It's similar to ABAP trace. So, but you will be accessing graphical. You will be able to see graphically hit list and for a report program or a transition. This is an alternative way to use the using SAP GUI ABAP trace user to detect the perspective entity. With this perspective, you will also create ABAP traces. The trace files are the same as those created using ABAP trace, which means that a trace created using any of these tools can be analyzed in the other tool as well. So here, which percentage of execution time was spent in ABAP, which percentage on database. So everything can be seen from ABAP profiling perspective as well. So I will be creating, I'll open the, um, I'll open the ECC system. So I will be opening the favorites. So if I open my program, source program, so I will be opening the program. So what I will be doing was, so I will be opening this OpenSQL as a secondary DB connection. So here, before executing, I will open this in ABAP perspective. How to open was, so Windows perspective, open perspective, ABAP profiling perspective. So ABAP profiling perspective was opened here. So we see I was in ABAP profiling perspective. So now I will execute this. This report program. As soon as when I execute this report program, so it is executing, taking time to execute. So as soon as when I execute it, so it is taking time to get the results. So I was in a web profiling perspective. If you say web traces, web trace requests. So once the program was executed, you will be able to see the percentage of execution time it taken in the web stack, percentage of time it took on the database stacks. Hit list of most time consumed programs and methods and database accesses so can be seen. So you have to expand this and you can go to a web trace requests. So you can have a refresh here. So right click and refresh it. So as soon as when you refresh it, as soon as refresh it, you will be able to see the so for this default trace. So you can see overview. What is the overview? So if you see the overview, if you see overview, it took 60% on the runtime consumption. It took 60% on the web trace, 30% on the database, 3% on the system. So overall, this was the variant which we used. This was the server which we used, aggregated by call position. So this was the user. The runtime consumption, it is showing about percentage, database percentage, and system percentage. You can even see the hit list from here as well. So hit list, it will give the hit list of most time consumed programs and methods. So database access. You can have a hit list. So it is displaying the hit list. So it's more or less the same as AbapTrace SAT, but it is showing ADT. It's have a more means we can say a graphical representation of it list here. You can analyze the flow of program as part of analysis. You can even see which ABAP programs are involved in there, or especially find useful places to set up a breakpoint as well. So ABAP card, so it will have. So if you wanted to see this, this is waiting for which screen is waited this much time. So you can see the executions, how much time it is executed. So even if you see the DB access as well, so it will take some time to execute the DB access as well. It will show you the trace for DB access. Yeah, so you can have, so you can see that in the report as well. So executions, bufferings, number of buffered access, total time it took. So everything you can see here. You can have a hit list as well. So you can have a list available for aggregate call position. So this is one more analysis tool in ADT, Web Perspective, same as the Web Trace. Next, moving on to performance analysis tools exercise. We have seen how to do SCI, ATC, SAT, and a web profiling perspective. First two was static checks, and these two was runtime consumption. So there are guided performance analysis as well. These guided performance analysis in these tools, you will be seeing the most water. They are guided performance tools such as SQL Monitor. So SQL Monitor is used to identify most important database access, the database which are most important to you. So these things will be accessed using SQL Monitor and the performance tuning work list. So SLWT. So it will give you SWLT. Give that combines static and dynamic performance analysis. Like it combines SQLM, it combines ST05 trace and gives you the SWLT. So it will. It's more or less a if you wanted to see entire dynamic and static and all the checks at one place, you will use SWLT as a tool. SQLM is most important database access. It will combine all the traces into a one tool. ST05 it goes deep analysis of database, in-depth analysis of database. If you wanted to check, then you will go for ST05. So if you go one by one, first I will go to SQLM. So SQLM is a new SQLM is a new tool for capturing SQL profile of a system or a transition. So entire system, if you wanted to have a trace, then you will use SQL Monitor, whether it is a production system, testing system, or any other system. Even in the production system, you will be able to have a SQL Monitor for the entire system. So entire system is not possible for SAT or static like code inspector checks. Entire system you are not able to trace. But using SQL Monitor, you will be able to trace entire system. So entire system's SQL profile will be traced, and it will give the aggregated data about all SQL requests executed in context of certain business processes and applications. These includes how often each request is executed, which tables were executed, the total runtime, how many records were fetched, and more. So SQL Monitor is a new development tool with ABAP 7.4. Uh, it also offered as a SAP Active Global Support add-on. It's an add-on actually. So the main goal of this tool was to run in the production environment, because this is where the real SQL profile of application can be observed actually. So in production systems, if you wanted to trace the entire system, then you will use SQL Monitor. The production system is the system which will be used by the customers. So if you trace when the customers are using particular application, you wanted to see how much time and how much response time your application is efficiently working, which programs or function models, or at which block of your code was affecting the performance, can be traced in the production system. When customers are using, you can be traced using SQL Monitor. Introduces only minimal performance overhead, and also data collection is done asynchronously without additional database affecting the runtime of actual business processes. Um, when a SQL Monitor is enabled, actually what happens was your ABAP kernel logs information about database accesses like transition, source code position, accessing tables, etc. Using runtime monitor infrastructure, it can do a file based as well. The data is transferred periodically to SQL Monitor using every 24 hours manually refresh possible. You can refresh as well. So the transfer is required for data analysis. In order to store results permanently, you will be saving them in a file. So I'll be going to system and will execute SQL Monitor. So what I will be doing was I will open the transition SQLM is a transition for SQL Monitor. So if you wanted to have a trace for entire system, so as of now system was not responding, we will wait till the um, system responds to you. There are two transitions as well. One was SQLM, other was SQLMD. So SQLM is used for SQL Monitor. So for creating the switching on the monitor, we will be using SQLM. For displaying the monitor, you will be using SQLMD transition. So I will be using SQLM. As soon as when I open this SQLM, you can have uh, um, SQL Monitor on all the servers on a selector servers. So if you see all the servers, you can give SQL Monitor on the date and time which when it wanted to have SQL Monitor. Suppose you wanted to have this SQL Monitor in your production system for a week or for a month, so you can start. It will give the time. Expiry date you can give. So from now, if you see the from now, if you wanted to start the SQL Monitor, so you can have from which time it should be activated, and what is the expiry date for uh, SQL Monitor. So I'm selecting now. So I'm selected server as of now instead of all servers. Clicking on OK. So it will ask for time of expiry. So I will be giving you now with some 1 week. I can give 1 week time, or I can give some time of 2 minutes, 5 minutes as well. In the production system, even I can give 1 month time also for execution. If you see, it is activated. So it is activated. Number of records, recorded time, last change time, some to refresh when it will refresh everything you can see. So you can deactivate as well whenever required. You can deactivate as well. You can display the data and export the data. So you can display the snapshots. Suppose if you um, execute a, I'm displaying a snapshot here. So you can select a snapshot. That means that if you executed SQL Monitor previously, suppose if you executed a long time back on a selected server, so you can select that snapshot and display that as well. So I'm selecting that, I'm just displaying that. So when I'm displaying that, I will be getting so DB executions, how many executions it took, and how many total DB time it took. So total DB records fetched. So in the entire system, not in the specific transaction report or function model, it fetches from the entire system. So entire system. So what are the selects? What are the open SQLs? So what are the rollback functions? Everything is fetched. What are the updates? So for the entire system, you will be able to get entire traces. So initial setup of SQL Monitor, you have to activate or deactivate the monitor via transition SQLM. When you launch it, it displays the current status. You can whether it is active or not on the application selected application server or on all other application servers. So I'm just going back. See, still it is active. After data has been collected, you can view collected SQL profile either by navigating from transition. Even you can, if I wanted to display my SQL MD is a transition for displaying my SQL monitor. So I can view on selected snapshots as well. So selected snapshots was suppose this snapshot I wanted to fetch. So each run it will create a snapshot for you. So each run it will create a snapshot for you. I'm displaying that as well. So you can display using SQL MD. You can give the criteria. Suppose you can give the criteria of display. So you can give which package you want. So which object type you want. So if you want which the object name you want a specific package. Suppose you can give that specific package. Suppose I want HANA as my package and click on OK. So it is showing that no data found. That means there is no data present for this package, but you can filter based on the package, object type, and a time interval as well. So snapshots, you can create a snapshot from SQLM. I'm going to SQLM again. So you can create a snapshot and manage a snapshot as well. You can display a snapshot is nothing but the runs which you have done when you switched on SQL Monitor for a month or a week in your production system. Once that execution was completed, it creates a snapshot. You can display all the snapshot here. Execution of all servers and select a server, and you can deactivation is done here. You can displaying of snapshot. You can see here. You can manage or create a snapshot as well. So you can manage a snapshot like by creating one, or you can edit and delete one snapshot here. So if you want to delete some, you can select and you can delete the snapshot as well. So so here SQL Monitor should collects data then when you activate it, it would collects from your production system, and the code optimized are usually planned in another system. So actually SQL Monitor is run when you switched on only in production system, but code fixes you will do it in code fixes you will do it only in your newer development system. So example, a development system or a sandbox system is desirable to able to export and import the collected data. That means that when you switch on the SQL Monitor in production system, you will have a snapshot. You will save that snapshot, and you will import that snapshot into your your development system and fix it, and you will and then export that to development system. That is how you will do it. So switching of your SQL Monitor done in production system for a week or a month, and fixing was done in development system. Once you fix that, it will the snapshot you will move that data into testing and then to production. So SQL Monitor supports exporting and importing snapshots data for this purpose. So here exporting data, so you can export the data. So which package? So you can export to object type, okay, and table data you can export as well. So suppose if I wanted to export a package, SQL Monitor data from a file actually. export only top 10 records. So you can export using a file. So you can display the data, also exported data. You can display it as well. Suppose current, I'm selecting it. The current display data. So current data was this. So top 200 records only it fetched, not aggregated, but top 200 records fetched the display data. Note that exported data can also be analyzed by other tools such as not you have a data and you want to expose that using SAP Lumira. You can visualize that using analytical transactions. So this is how you do SQL Monitor. So SQL Monitor is identify most important database access. So most important database access. So you can do it using SQL Monitor. So display snapshots, select snapshot, which is executed previously. I'm showing it when it is executed previously. So all the things. So now I'm going to next transition, next tool called performance tuning worklist SWLT to combine. It combines both static and dynamic performance analysis results. Like if you go to SWLT transition, so SWLT is a transition. So SWLT is a transition for performance tuning worklist. Here in general you can give which package you want, suppose object type which package, or you can avoid the package as well. So you can give static checks. So if I wanted to give code inspector checks, you can give the code inspector checks as well. And then SQL monitor as well you can give. So you can select a snapshot from your executor snapshot. You can select a snapshot as well. So you can create a own snapshots as well. So own, so show all snapshots, show all the snapshots. You can select any of the snapshots. So and then you go back as WLT. I'm going. So it's basically tool which gives static checks. So static checks like ATC checks, code inspector checks. So these things aggregated, so you can aggregate them, and you can select SQL monitor as well. So you can use SQL monitor. You cannot use it. If you don't want to use SQL monitor, you will unselect it and select on OK. So as soon as you select on OK, it will give you a combined priority list. You say priority one. So priority one was here, select start statement, existing no field checks. So if I go to this CDS view entity, so static checks, it gives me static check. So if I go to this additional information, it is giving me. So I have used a select star for this table. So it is giving me priority one. So priority one, so many priorities was there. So it giving me a ranked work list saying that select start statements are probably in loops. I have accessed something in a loop here. So it is giving me priority work list. Select star, select for all entries can be transformed. So if you see this, so if I double click here, so I will be able to see this statement. So you have used select for all entries. So this can be transferred without a check. So LT address is there. I have to check this before you use a select for all entries. So it is giving me a ranked work list like priority one, priority two. So if I'm go inside, I will get the priority one, priority two as well. So if I can use SQL monitor as well with the snapshot. So as soon as when I click on here, so then I'm giving the SQL monitor. So it give me a result finding saying how much DB time it took. So if you see, it doesn't execute anything now. It is giving me results 19 findings. So total, it's the first screen was total results overview. So how much time it took for SQL monitor results, static code check results. So this right side block gives SCI and ATC checks. Left side gives SQL monitor checks. In this block gives the combined results of SQL monitor and static code checks. Just clicking on back. So total DB execution time and total DB records it took. I can select as well. So I'm clicking on back. So as WLT, again I'm going. Now I won't give any package. So I'll go to SQL monitor. So and click on OK. If you see this, before I give package name JDABAP underscore HANA package. That's why. Now if you see 299 findings for entire system, this is a overview. So if I select anything, So if you show this is the SQL monitor. So this I took this much time to, if I double click here, so the first one was the SQL monitor. It is fetched from the SQL monitor. So if I use something else, this is also SQL monitor check. So if I wanted to go some static code check also, I can go from the static code check. So there is no static code checks find for this. So for each batch, if there is any static check, it will display here at the right corner. Click. So I'm just going to select. So there is no static checks. There is no static checks. So for each statement, what is the SQL monitor results? What is the static code check? So everything can be seen here from the single record work list. So total DB time, DB executions it took. So what is the total DB execution time it took? Total mean time, everything is executed, which shown here. It's a combined tuning work list, which where you will be saving the combined results of both SQL monitor and um, so if you wanted to have performance optimizer, it makes sense to combine the results of both static source code analysis with ATC and CI. So it will be displaying in one block. It will be displaying in one block static checks, and SQL monitor will be displaying in another mock. Ranked work list will be displaying in the other block. Now um, we'll go to next trace called ST05. So this is used for in-depth analysis of database access. So in-depth analysis of database access. So here, suppose if I have any report, so I have a report called /SE80, SE38. So I'm executing report. I'm just SE80. So I have a program. So if I execute this is my report program, which we used previously as well. So if I wanted to trace this, how much time this select took without a wait condition, I can do using SQL trace as well. So it gives only SQL trace. Suppose I can go to transition /ST05. Only SQL trace will be visible here. So if you see the traces such as SQL, you can take buffer trace, NQ trace. NQ is nothing but locking and unlocking. How much time it is taking to lock and unlock? How much time it is taking to buffer? Means buffer trace, buffer like getting the data and fetching into data buffer. So when you execute a select query in the database access, in first time it fetches the data. If it is a buffer table, so it will fetch the data into buffer, and next time when you access the same select query, it fetches the results from the buffer instead of the database. So how much time it took, you can access from from ST05 buffer trace and RFC trace also you can take from. If you are fetching any details from an RFC, means a remote function call, then also you can take that. HTTP trace can be taken. So some of the traces can be taken here. The procedure was, so we have to open ST05 tray, and we have to select SQL trace, activate it. So if you see user activated the SQL trace, now what I will be doing was I will go to this report and click on execute. So once the execution was stopped, so till the execution was stopped, I need to wait. So if you see, it's still running. So till this report was completed, I have to wait for to end the trace. So once this report execution was completed, then I will be deactivating the trace. So I'm waiting for the program execution to complete so that I will be deactivating the trace. So since I have using a star statement from 3 or 4 tables, I'm using a database access inside the loop, it taking so much time. So my program execution was completed now. I will go to trace here. I will be deactivating the trace. So before I activated, now I deactivated. Now I am displaying the trace. So I'm executing the trace. Yes, 5,000 trace records are available here. So I'm just selecting everything. So I'm selecting it. clicked on OK. It is taking time to fetch the trace. If you see, in all this report program was this records fetched was 1172 records it fetched. Duration it took was in microseconds, um, 49,129 milliseconds it took. So you can see which statement is executed fast. Suppose which statement is taking time, everything you can check here. Suppose I'm just moving. Suppose I will take a trace of a normal simple report. Suppose I'm just going back to my report. So I'll go back. What I will be doing is I will be editing this. So what I will be doing is I will just comment this loop statement. I'll just execute only this select query with a where condition. The where condition, I will try to execute this. So I'm activating it. So I have only one select statement now. So what I will be doing was I will go to trace now, ST05, activate the trace. And I will, so if you see it's activated, I will go to this report and execute. Now only one select was there. It is easy for me to identify. So it's, if you see, the trace was executed. So report was executed. Now I will deactivate the trace. So now display the trace and execute. I think it's not yet completed. I'll just go back again, back, ST05. So I'll execute it again. I will activate the trace. I will go to this report, execute it, go to the statement, go to my trace again, and deactivate the trace and display the trace. So execute the trace result. See this, the object name, you can see object name, which object name was executed. So what I will be doing was I can filter on the object name as well. Just checking for the table. Mark was my table. Just filter the mark, click on OK. So I think there's no mark here, so I have to wait here. Number of traces is was 5. It was 5,000. I'll give here 0, 100. I'll go back, open again ST05. So now my mark was there. I'll try the trace again to show the simple result. I'm executing it again. Activate trace and go for execution. Go here and then deactivate the trace. Display the trace. So here instead of 5,000 number of traces, some 100 I will use and click on OK. I'm selecting the main traces. Yes, subject name. I think it doesn't result, it doesn't give the entire trace because this is in a secondary DB connection. Suppose if I select this mark, it is there here, but when I open any trace, so open the report, trace based on the object name, mark, clicking on OK. Yeah, now it fetched the object name mark for me. It took 1 millisecond. So if you see the entire thing which is took was just 1 microsecond for me. So if double click on this, I'll be getting the select statement, how it executed. Since I executed select star, this is the open native SQL, means it converts the trace. The when you do any open SQL statement on your web report program, when you write our select statement and execute it, so it will be converted into native SQL to understand to the DB interface and the DB database layer. Since DB access understands only native SQL, so it will convert your OpenSQL statement to native SQL. So this is the native SQL statement executor. So you can see how it is executed. So it is, you can see the execution plan as well. So I'm just going inside. So this is the execution plan. You can see the execution plan, display the execution plan as well for record the statement. So for the record statement, what is the execution plan? So it's column search. It has done a column search on column table. That was the execution plan it is taken. That's all. So step-by-step execution plan. Graphical explain also you can do. System not found as of now. So go back. Selecting it. You can display individual records as well. So individual records, duration. The records was fetched was 3. Duration was 1 millisecond. So here I'm doing a execution plan. The statement, the trace records. So only for this statement we will be having here 32 records, 32 microseconds it took. This is the select SQL statement. So execution plan explains you the database specific will look different from the each database platform supported by SAP. So mainly it converts to native SQL and it will give the trace result. So another tool, this is another tool for runtime performance analysis, ST05. This tool in particular analysis database accesses. It can thus be used for a deeper analysis of one's analysis with a web trace or a web profiling um, perspective indicates that database access could cause the performance issues here. So this is ST05 trace. I'm just going back. So the procedure to activate SQL trace was, so you will activate the trace first. We'll go to the transition, activate the trace, run the report or the transition, even you execute the transition as well. Suppose I'm just going back. So what I will be doing was ST05. So entire application also can be traced with SQL. So I will be giving now RFC and then buffer NQ trace also I'm giving now. So it is possible to give NQ trace and RFC trace also with these. Now what I will do is I'll go to BP. Okay, so I'll start one BP transition. Okay, so now this is my BP transition. So I'll go here and activate the trace. So NQ trace RFC SQL trace was on. So now I'll go to my transition. I'll just click on one of the BP to get this BP will fetch many records. Fetched. So and I'm clicking on address details of this BP. So now I'll deactivate this trace. Display the trace. So I'm clicking on OK. Yes. It will fetch me all the records. So it took 45 total amount took gross amount took it fetched the records 20 and 101 records it fetched. Total time it took was in microseconds was this. So if you wanted to get the set filter based on BUT 000, this is a table where you will get object name. So just executing it. So for entire transition as well, you can take the trace. What I meant from here was. So this is how you do SQL trace from ST05. It most the similar. So NQ trace will give how much time it takes to NQ and DQ. Buffer trace will be the buffering time it takes to fetch the data from database table to DB layer. Yeah. So continuing to slides. So I have shown you the exercise guided performance analysis for SQLM, SWLT, and ST05. So performance rules. What are the performance rules and guidelines for SAP HANA? So performance rules and guidelines for SAP HANA was you should keep the result set small. That means that so when you these are golden rules we can say for SAP HANA. So you should keep your result small. That means that you should use a where condition for your select query or having conditions or group by conditions for your select query. So that the result you that means that you are doing a filtering on your query to fetch the minimum amount of results which are required. So irrespective of if you have only if you need only 3 or 4 records and if you are fetching entire records from your query, it doesn't make any sense. It affects huge performance. So keep your results as small. So second one was minimize amount of data transfer. So select with a field list. So when you are transferring a field list from your database layer, when you query anything from your application layer, it fetches from the DB layer to application layer. So when you're fetching the data is transformed from your DB layer to application layer and application layer to DB layer. So here, instead of selecting star, better you use a field list. So wherever necessary, if you want only 3 fields, you select the field list so that you will minimize the amount of data transfer. Minimize number of database accesses, minimize amount of data transfer, this means data access. Instead of hitting the database to, one at a time, suppose if you use joins. So joins are subqueries. Instead of using joins and subqueries, use joins and subqueries instead of nested select loops or select for all entries. So use select for all entries, joins or subqueries instead of select in a loops. So when you use a selects inside a loop or database accesses like insert, update, selects inside a loop, that means that for every loop you are hitting your database once. Instead of that, select everything outside of the loop by using select for all entries or select with a join or a select with a subqueries, and you minimize the number of database accesses. So, and minimize search overhead. So the same as solution where clause using non-indexed fields are not bad anymore. That means that if you have a database table with secondary indexes, so the index will be having 3 or 4 columns. So better you use in your where condition of a select query all the full the index. You use the index functionality so to minimize the search overhead. So it will if you use all the index functionality in your where condition columns, it will minimize your search overhead. Keep unnecessary load away from DB. So it means that push data intensive calculations to SAP HANA. That means that you do only results means you should do your calculations and application logic inside your database layer. The performance rules and guidelines for SAP HANA was this. So some of the performance guidelines for SAP HANA was select star statements. So select star statements means so avoid the select star. So instead of star, use field list. Where condition for a select list, you should use a where condition for your select list. You should filter your select queries. Use check exit or no statement in select and unselect. So when you have a select and unselect statements, better you without any check or exit or no statements in a select and unselect, it will be useless. So and database hints needs to be improved, so needs to be removed. So database hints are nothing but hints you are going to your select query to do what things to do. So these things needs to be removed. It's no longer supported now. So native SQL is removed. Only open SQL should be used. If you have any native SQL, you should avoid that. Select statement that bypasses table buffer. That means that if you have a table with buffering, like single record buffering was used for that table, then you should use select single in your select statement. Otherwise it will bypass the table buffer. Select for pool or cluster tables without order by. So all your pool or cluster tables were moved to transparent tables in um, SAP NetWeaver 7.4 and above. So better you use order by. Changing database access inside the loop, that means that use of select, update, delete inside the loop should be avoided to get the best performance. So these are the some of the performance guidelines for SAP HANA. So when you practice, when you are doing any coding for your web app, you should follow these guidelines. So to get the efficient performance, to avoid unnecessary bottlenecks. So for your performance, so better you follow these guidelines to get the better results. So these are some of the rules for your performance guidelines for SAP HANA. So from this, we came into end of this unit taking ABAP to SAP HANA. That means in this unit we discussed how to access SAP HANA DB by using OpenSQL and as a secondary database. Using OpenSQL, how you will be able to access SAP HANA tables you have seen here. And performance tools we discussed, such as static performance, like potential performance issues can be checked using SCI and ATC, so Code Inspector and ABAP Test Cockpit. And runtime consumption can be analyzed using SAT and ABAP profiling perspective. That is nothing but ABAP Trace. SQL Monitor is very important here. It is used to identify most important database accesses. It is mostly used in the production systems when users, all the customers or the users are using an application in the production system. So we will be able to trace how what are the performance affected reports, blogs. So we will be able to see them in the production system. So we'll take the snapshot and export it into development system, import into development system, fix them and move it into fix them and move it into production system again. SWLT is again a nice tool to see, a single tool to see the priority work list like static and dynamic performance results. So ST05 we have seen SQL trace for in-depth analysis of DB access. So and finally we have seen performance rules and guidelines for ABAP and SAP HANA. So if you have HANA as a database and you have performance rules to be followed, was we have seen like select star, and we should select statements that bypasses table buffer, and some select with where clause, and select for all entries needs to be used instead of select in a loop. Better you use joins and select for all entries, and then use subqueries as well. And database accesses inside the loops is avoided, so you should select everything outside. And some of the things like um, you should keep a minimum amount of data transfer from your database layer to application layer. So search overhead, you should use indexes, secondary indexes. In HANA, if you see every field was use secondary index. So every field acts as an index. That means you need to create an index there just to use a where condition wherever necessary. So these things give you better performance. So for a developer to write efficient code, and to if you use these performance rules and guidelines, then it will affect, it will give the best results for you. Yeah. Thank you. From this session, we completed the unit 7, taking ABAP to SAP HANA. Thank you.